Welcome back. It's great to see you again. So let's talk about analysis. We've learned how to ask the right questions, prepare data for exploration, and then process that data to make sure it's squeaky clean. Now it's time for the heart of the process, the actual analysis. Finally, right? But what is analysis? Basically, analysis is the process used to make sense of the data collected. It means taking the right steps to perceive and think about your data in different ways. The goal of analysis is to identify trends and relationships within the data so that you can accurately answer the question you're asking. To do this, you should stick to the 4 phases of analysis: organize data, format and adjust data, get input from others, and transform data by observing relationships between data points and making calculations. Okay, let's apply the 4 phases of analysis to a real-world scenario. Imagine you want to buy a gift for your friend Zara's wedding. The problem is you're not sure what to get her. Fortunately, you have a ton of data from her wedding website. But instead of reading all the data on her website and scrolling through a photo album of her and her partner, you go straight to the online registry, a wish list of gifts they'd enjoy. The registry is like a data set that you can analyze to make a decision. Now that you're checking out organized data in the registry, you want to make sure that the list of data, or gifts in this case, is formatted in a way that's easy to reference. Formatting data streamlines things and saves you time. Scrolling through hundreds of gifts can be time-consuming, so instead, you can adjust the data in a way that makes it easy to digest by filtering and sorting your data. You have a budget you want to stick to, so you sort the gift prices from low to high. You then filter prices to include gifts that are within your budget of $60. So you're working with a newly formatted list of data. At this point, it's good to remember that input from other people can also be really helpful when analyzing information and making decisions. You can check the list of gifts to figure out if anyone else has already bought any of the items. You realize a few of the items in the list have been purchased, and this informs your decision. When analyzing data, gaining input from others is important because it gives you a viewpoint you might not understand or have access to. On top of gaining input from other people, it's also important to seek out others' perspectives early. That way, if they predict any obstacles or challenges, you'll know beforehand. The people you look to for input don't have to be experts to be helpful. Sometimes all you need is for someone who's familiar with the topic or data you're considering. In our example, that would be Zara's wedding guests who are purchasing gifts from the same online registry. They probably aren't wedding gift experts, but their collaborative effort to mark off the item they purchased can help you figure out what not to buy, which will prevent Zara from getting the same gift twice. So in the end, getting input is valuable to your analysis. This brings up the last step of the analysis, transforming data. Transforming data means identifying relationships and patterns between the data and making calculations based on the data you have. Going back to our example, you were able to find a gift that you knew Zara would like and one that fits your budget. You were also able to choose a gift that wasn't already purchased by someone else. By finding the relationship between these data points, you chose, purchased, and sent a gift that would answer the problem you wanted to solve. The beauty of the analysis process is that you probably already analyze situations in your everyday life. Whether you're analyzing data in your personal life or in your career, these 4 tasks can help you make better decisions. And the more you do it, the more comfortable you'll feel with the process. I hope this gives you a better understanding of the basics of analysis. As we move forward, we'll check out how to locate data for analysis, both in a spreadsheet and using SQL. When you're ready, you can go ahead. See you soon. Let's jump back in. Right now, we're in the analyze phase of the data analysis process. And even though each phase is unique, data analysts make decisions about organization throughout all of them. That's what we're talking about here. organization. It's super important that you keep your data organized throughout your analysis. How your data is classified and structured will impact your findings, whether you're working in a spreadsheet or a database. And once you know how your data is organized, you'll be able to capture or collect the information you need. Most of the data you'll use in your analysis will be organized in tables. Tables help you organize similar kinds of data into categories and subject areas that you can focus on as you analyze. For example, this basic database has tables for car dealerships, product details, and repair parts. Each table then has several fields of data like branch owner and the cost of repair parts. You can use these tables and fields to help you decide how to move forward with your analysis. The structure of this database can help you decide which data you need to pull to meet your objectives. For example, the total number of a particular brand of car sold, or a repair part for a specific make and model of a car at a certain branch. Tables allow you to make decisions about data types. They help you to figure out what variables you need and the data type those variables should have. So if you have a database where you need to convert a data type during your analysis, you can do that by using the cast command in SQL or any other method that you learn on the job or from your own research. Like this example, where we converted a purchase price column to be a float instead of a string so that it was in a numerical form we could use for calculations. If you're performing your analysis in a spreadsheet, you want to make sure that the columns and rows are effectively organized. You can even hide columns that you won't need for your analysis or that show duplicate information. Once you have the data organized and formatted, you'll be ready to sort and filter it to find the data you need. We'll cover sorting and filtering soon. But for now, just know that both filters and sorts are affected by the type of data we're working with. The bottom line is that it's important to have your data in the right format. So always be prepared to adjust no matter how far into your analysis you are. That's all for now. Coming up, we'll show you what filters are all about. Bye! Earlier we talked about why you should organize your data no matter what part of the life cycle it's in. Just like any collection, it's easier to manage and care for a group of things when there's structure around them. Now, we should keep in mind that organization isn't just about making things look orderly. It's also about making it easier to search and locate the data you need in a quick and easy way. As a data analyst, you'll find yourself rearranging and sifting through databases pretty often. Two of the most common ways of doing this are with sorting and filtering. We briefly discussed sorting and filtering before, and it's important you know exactly what each one does. Sorting is when you arrange data into a meaningful order to make it easier to understand, analyze, and visualize. Sorting ranks your data based on a specific metric that you can choose. You can sort data in spreadsheets and databases that use SQL. We'll get to all the cool functions you can use in both a little later on. A common way to sort items when you're shopping on a website is from lowest to highest price, but you can also sort by alphabetical order, like books in a library. Or you can sort from newest to oldest, like the order of text messages in a phone. Or nearest to furthest away, like when you're searching for restaurants online. Another way to organize information is with a filter. Filtering is showing only the data that meets a specific criteria while hiding the rest. Typically, you can use filters when you want to narrow down the amount of data you want to sift through. Say you're searching for green sneakers online. To save time, you filter for green shoes only. Using a filter slims down larger data sets to smaller subsets that are relevant to what you need. Sorting and filtering are two actions you probably perform a lot online. Whether you're sorting movie showtimes from earliest to latest or filtering your search results to just images, you're probably already familiar with how helpful they can be for making sense of data. Now let's take that knowledge and apply it. When it comes to sifting through large, disorganized piles of data, filters are your friend. You might remember from a previous video that you can use filters in spreadsheet programs like Excel and Sheets to only display data from rows that match the range or condition you set. You can also filter data into SQL using the where clause. The where clause works similarly to filtering in a spreadsheet because it returns rows based on a condition you name. Let's learn how you can use a where clause in a database. We'll use BigQuery to access the database and run our query. If you're joining us, open up your tool of choice for using SQL and reference the earlier resource on how to access the dataset. Otherwise, watch as the where clause does its thing. Here's the database. You might recognize it from past videos. Basically, it's a long list of movies. Each row includes an entry for the columns named: movie title, release date, genre, director, cast members, budget, and total revenue. It also includes a link to the film's Wikipedia page. If you scroll down the list goes on for a long time. Of course, we won't need to go through everything to find the data we want. That's the beauty of a filter. In this case, we'll use the where clause to filter the database and narrow down the list to movies in the comedy genre. To start, we'll use the select command followed by an asterisk. In SQL, an asterisk selects all of the data. On a new line, we'll type from in the name of the database, movie_data.movies. To filter the movies by comedy, we're going to type where, then list the condition, which is genre. Genre is a column in the dataset, and we only want to select rows where the cell in the genre column exactly matches comedy. Next, we'll type the equal sign and write the specific genre we're filtering for, which is comedy. Since the data in the genre column is a string format, we have to use single or double quotations when writing it. And keep in mind that capitalization matters here, so we have to make sure that the letter casing matches the column name exactly. And now we can click Run to check out the results. What we're left with is a shorter list of comedy movies. Pretty cool, right? Here's something else that you should know. You can apply multiple filters to a database. You can even sort and filter data at the same time for even more precise results. As a data analyst, knowing how to sort and filter data will make you a superstar. That's all for now. Coming up, we'll get down to the nitty-gritty of sorting functions and spreadsheets. See you there. Sorting is amazing. Not only does it add order and meaning to your spreadsheets, it also gives you the power to reimagine data altogether. When you sort data based on a specific metric, you can uncover new patterns and relationships within data sets you might not have otherwise noticed. This is especially true for spreadsheets, which you'll use a lot in your work as a data analyst. Knowing how to sort data in spreadsheets can make you a stronger and more confident analyst. In many ways, sorting relies on your creativity to reimagine the information you have in front of you. In spreadsheets, you can sort data by ascending or descending order using numbers or letters. If cells are labeled with color, you can sort them by color too. When sorting data in a spreadsheet, you can choose to sort sheet or sort range. If sort sheet is applied, all of the data in a spreadsheet is sorted by the conditions of a single column, but the related information across each row stays together. On the other hand, sort range doesn't keep the information across rows together. When you sort a range, you're selecting a specific collection of cells or the range that you want the sorting limited to. Nothing else on the spreadsheet gets rearranged but the specified cells. There's two methods for sorting spreadsheet data. One involves using the menu, the other involves writing out the sort function. For now, we'll focus on sorting with the menu. We'll get to writing out functions later on. Now, depending on the program you use, the process might seem slightly different, but the instructions and concepts we discuss will be basically the same. Okay. Back to sorting with the data menu. To give you an idea of how to do it, we'll use the movie spreadsheet. Let's check it out. In this example, we'll sort movies by release date. So we'll head to column B, which is listed as release date, and click on the B button to highlight all the cells in the column. From there, we'll head to the Data tab in the menu. Now you have two choices: sort a sheet or a range of data. You'll notice that we've selected just the release dates, but these release dates are specifically related to the movies in their row. In this case, you want the release date and the movie title to stay in the same row as you sort because they're related. To do this, you'll want to sort sheet. This will keep all the data together by row, no matter how you sort it. Depending on the order you want the release dates to be in, you can sort from A to Z, which also ranks the dates numerically, or you can sort from Z to A, which will sort data the opposite way. Since we want the release dates to be in order, we'll click Sort Sheet by column B from A to Z. And there you go. You just sorted a sheet of data using the menu. Now the movies are arranged in chronological order based on release date. Okay, let's say you want to sort data in a specific column, but don't need the cells in that column tied to a specific row of information. Instead, you want to isolate the column's data and sort it on its own without affecting how the rest of the sheet's arranged. For fun, we'll use the movie title column in this example. First, we'll select the column we want to sort, column A. Clicking on column A highlights all the cells in the column which contain the movie titles. Then we'll go to the menu and click Data. Because we're isolating the column from the rest of the sheet when we sort this time, we'll click Sort Range by column A. For this example, we'll sort the movie titles alphabetically from A to Z. And that's it. You'll notice that Sort Range doesn't keep the rows together, so the data is a bit jumbled. You'll probably end up using Sort Sheet more often, but it's important to understand them both so you don't accidentally get them mixed up. You've just sorted data in a spreadsheet using the menu, and you've learned how to sort data by an entire sheet or by a range of cells. That's something you'll be able to take with you wherever you go as a data analyst. Coming up, we'll learn about the second way to sort in a spreadsheet, by writing out a function. We'll also take sorting to the next level by custom sorting your data. See you there. Now that we've laid the groundwork, it's time to move on to more advanced ways to sort information. We've talked about how there's two methods of sorting data in spreadsheets. The first method uses the Data tab in the menu of your spreadsheet program. The second way to sort information in a spreadsheet is by writing a sort function. In spreadsheets, functions are preset commands that perform a specific process. So in this case, the sort function, as you might be able to guess, sorts your data. Let's check out this spreadsheet of party plans to witness the sort function in action. It's good to keep in mind that when you use the sort function, you're actually changing the existing data set. Unlike when you use the Data tab in the menu, which rearranges the data in the original data set. The first arranged set of data is our original data set of guests and some information about them. So let's say you want to sort the party guests by table to get an idea of who will be sitting where. To do that, start by typing a function in an empty cell. Just like any function, you do this by typing the equal sign and then write sort after it. After your first open parentheses, reference the first cell in which data is collected from. In this case, that's A2. Then you'll include a colon and write the last cell you want included in the function, which is D6. A2 colon D6 is the range for this function. Next, write a comma to separate the range from what we're sorting by, which is column B. You should keep in mind that this part of the function doesn't recognize column letters. So in this case, we use the corresponding number instead, which is 2, since column B is the second column in our range. Now add another comma. In this next part, you'll need to decide whether you want the data in this column to be in ascending or descending order. A true statement is in ascending order, and false is descending. Because we want the tables to be listed starting from table number 1, we'll write true for ascending order and then in the function with a closed parentheses. Now let's see our function play out. Our party guests are now sorted by which table they're seated. Once you have an idea of the data you want to be sorted and how, applying functions to your data is simple. Now you have 2 different tools in your tool belt for sorting data. After you've tackled writing sort functions, you'll want to customize sort orders too. A customized sort order is when you sort data in a spreadsheet using multiple conditions. This means that sorting will be based on the order of the conditions you select. Let's go back to our party spreadsheet. Imagine you want the guests to be sorted by whether or not they've been sent an invitation. And based on that, we want those guest names to be listed alphabetically. You can do that easily with the sort range option under data. First, highlight all the data in the set from cells A1 to D6. Then under the Data tab in the menu, click Sort Range. In this case, check Data has a header row, which makes sure that the title of the column isn't mixed into the sorting. Then we'll make sure it's being sorted by sent invitation. Here we want the no responses first and the yes responses second. So we'll make sure A to Z is clicked to sort the responses in that order. Because we want to add an additional sorting condition, we'll now click on Add Another Sort column. The guest names should be in alphabetical order. So let's select guest names and sort from A to Z. Then we'll click Sort. And voila! You've officially applied a custom sort order like a champ. Okay, so you've tackled sorting in spreadsheets by sheet, by range, through the menu, and by using a function. On top of all that, you've added to your organizational skills by learning how to create custom sort orders. Pretty soon, you'll learn another powerful tool, how to sort data using SQL. Even though databases can sometimes be a lot to digest, learning these skills gives you the power to rearrange data in a way that makes sense to you. Once you've sorted data in a way that really clicks, you'll understand why it's so valuable to you as a data analyst. If you're hoping to learn about sorting in SQL this time, you've definitely come to the right place. So far, we've sorted spreadsheets through the menu and with a written function, which brings us to the next part of our learning, more sort functions, but this time in SQL. Data analysts love playing with the way data is presented. Sorting is a useful way to rearrange data because it can help you understand the data you have in a different light. As you've probably already noticed, a lot of things you can do in spreadsheets can also be done in SQL. Sorting is one of those things. We've talked about using SQL with large data sets before. When a spreadsheet has too much data, you can get error messages or it can cause your program to crash. That's definitely something we want to avoid. SQL shortens processes that would otherwise take a very long time or be impossible to complete in a spreadsheet. Personally, I use SQL to pull and combine different data tables. It's much quicker than a spreadsheet, and that usually comes in handy. Here's something pretty helpful you can do with SQL. You can use the order by clause to sort results returned in a query. Let's go back to our movie spreadsheet to get a better idea of how this works. Feel free to follow along in a SQL tool of your choice as we go. As a quick refresher, we have a database of movies listed with data like release date, director, and more. We can sort this table in lots of different ways using the order by function. For this example, let's sort by release date. First, we have the select function and an asterisk. Keep in mind that the asterisk means all columns are selected. Then we have from and the name of the database and table we're in right now. Now let's check out the next line. It's empty, but that's what we'll write our order by function. The order by command is usually the last clause in your query. So back to the actual sorting. We'll type order by with a space. With this clause, you can choose to order data by fields in a certain column. Because we want to sort by release date, we'll type release date. By default, the order by clause sorts data in ascending order. If you run the query as it is right now, the movies will be sorted from oldest to the most recent release dates. Let's run the query and see what we've got. You can also sort the release dates in the reverse order from the most recent dates to the oldest. To do this, just specify descending order in the order by command written as DESC, D-E-S-C. Let's run this query. As you'll notice, the most recently released films are now at the top of the database. In spreadsheets, you can combine sorts and filters to display information differently. You can do something similar in SQL too. You might remember that while sorting puts data in a specific order, filters narrow down data so you only see data that fits the filter. So for example, let's say we want to filter movies by genre so that we're only working with comedies. But we still want release dates to be sorted in descending order, from most recent to oldest films. We can do this with the where clause. Let's try that now. First, we'll check that the order by clause is always the last line. That makes sure that all the results of the query you're running are sorted by that clause. Then we'll add a new line for the where clause after from and before order by. Here's what we've got so far. From there, we want to type the column we're filtering for. In this case, we want to filter the database for comedies. So after the where clause, we'll type the column list name as genre. Now we'll add an equal sign after genre because we only want to include genres that match what we're filtering for. In this case, we're filtering for comedy, so we'll type comedy between 2 apostrophes. Now, if you check out the entire query as a whole, you'll notice that we're selecting all columns. And we know it's all columns because that's what an asterisk means. The from clause specifies the name of the movie database we're using, and the where clause filters the data to include entries whose genre is specified as comedy. And then in the last line, we have the order by clause, which will sort the data we've chosen to filter by release dates in descending order. This means when we run the query, we'll only have comedy movies listed from newest releases to oldest releases. So let's run it and figure out if that's the case. Cool. Check out all those comedy movies and the way those dates are sorted. Now, let's take this query a step further. We'll filter for 2 conditions at once using the AND filter. Working off the query we've been using, we'll add a second condition in the where clause. We'll keep the sorting the same. Let's say you wanted to filter by comedy movies and movies that earned over $300 million in the box office. In this case, after the AND function, you add the revenue condition by typing revenue. From there, you'll specify that you only want to return films with revenues over $300 million. To do that, type the greater than sign and then the complete number of 300 million without commas. Now let's run the query. Here, the data only shows comedy movies with revenues of over $300 million, and it's sorted in descending order by release date. It looks really good. You just filtered and sorted a database like it's your job. And with practice, one day it can be. And just like that, you finish another step in your data analyst journey. By now, you really dug and learned about the analysis process, with a special emphasis on how organization can change how you go through your data. You also learned about both spreadsheets and SQL, and how to sort and filter data in both types of programs. To help you get more comfortable using spreadsheet and SQL features, you'll be getting some materials you can use as a resource. Coming up, we'll check out how an organizational mindset can take your analytical skills even further. We'll also cover converting, formatting, and adjusting data to combine information in a way that makes sense. Learning those skills early on can make your work as a data analyst much more efficient and effective in the long run. See you soon!
Congratulations on finishing this video from the Google Data Analytics Certificate. Access the full experience, including job search help, and start to earn the official certificate by clicking the icon or the link in the description. Watch the next video in the course by clicking here, and subscribe to our channel for more from upcoming Google Career certificates.